Yeah.
Cloud native at scale.
Yeah. Okay. Let's get started. So welcome everybody. This is Joshua Hurst. I'm one of the organizers here at Cloud Native at Scale. And I just wanted to show you in case, because we have a lot of people that come from Eventbrite and then sometimes LinkedIn that aren't a part of our meetup. So I just wanted to invite any of you who are not a part of this, just search Cloud Native at Scale, San Francisco. We started this community earlier this year. We run a few other meetups for those of you who don't know, but this is a relatively new community. We already have 116 members. I think we've added about at least 25 since our last event. So we're all about connecting the cloud native engineering community through, we do case studies, shared learning through speaker talks, fireside chats, live demos. Hopefully one day social events, if we ever get back to that. So welcome everybody. I know we have people from all over the world. I hope you're doing well. Good morning, good afternoon. Thank you for joining us. Also, another quick announcement. I just created this last week. There's not much going on here on LinkedIn, but I created a LinkedIn corporate page for our meetup community here and invite you to join this. Like I said, we just got this going. Over the next few weeks and months, we're going to try to get this going and share a lot of great content about cloud native technologies. So we got that. And then for tonight, we have Daniel and Rajesh, event-driven and cloud native systems, solving the interoperability puzzle. We're here for about an hour and we should end right on time. We try to keep it short because given the fact that everybody attends Zoom calls all the time, we just think it's better to keep it short. So we'll do an hour. So cloud events, for those of you who don't know, you can go to cloudevents.io as a specification for describing event data in a common way. And Rajesh will be getting into that a lot more this evening. This is our agenda. So we'll do some quick introductions. Welcome. We'll have about a half hour for a presentation. It won't be all presentation. We'll kind of have a little bit of presentation, Q&A, a little bit of fireside chat, all mixed up all together. So Rajesh Iyer is the platform engineering manager at American Express, and I'll have Daniel introduce him in just a minute. And Daniel Cohen, a good friend of mine, partner in crime here at Cloud Native, is going to be our host. He's the director of customer success at Styra. And so for those of you who don't know, Styra is the founder and maintainer of OPA, Open Policy Agent, which is a graduated project at CNCF, so Cloud Native Computing Foundation. He's previously held positions, leadership sales positions at companies such as PagerDuty, AppDynamics, DataStax. Also has a lot of experience with client-facing technologies when he was the VP of technology at JPMorgan. So he's a perfect fit for Rajesh, at another financial institution. And I will turn it over to you, Daniel. Do you want to give us an update on Cloud Native or the graduation here?
I think you did a pretty decent job. But yeah. I will mention, if you don't know what Open Policy Agent is, it's an open source project with the Cloud Native Computing Foundation. It provides unified authorization across the cloud native stack. Really what it is, it's a general purpose decision engine, and you can create rules that, evaluate context, data, policy to make decisions. That's really what it is. We just went through the graduation process at CNCF, I don't know, a month or two ago. Super fun process, and it's been an absolute joy and an honor to go through it. But that's about that on us. I think you did the intro on Rajesh, but going back in his history, he's been at even more financial institutions than I have. So I think that our topic today, if you've ever built financial software, if you've had to support financial software or anything like that, this should be relevant. I've helped build event-driven systems before as well. So hopefully we'll have a decent discussion about this. Rajesh, you want to share and jump into your slides from here, and we'll have a good chat.
You should be able to, Rajesh. I think you're good. Yep, we can see it. You're good.
You're on mute though, brother.
Unmute. Rajesh, unmute. There you go.
Okay, can you guys hear me okay now?
Yeah, perfect.
Yeah. All right. You want to introduce your premise today and tell us a little bit about what we'll be discussing?
Yeah. So, hi everyone. My name is Rajesh Iyer, and can you guys hear me okay? Or
Yeah.
is there a lot of sound?
Yeah,
Okay.
I don't know, somebody put it on mute. Yeah. Go ahead, Rajesh.
Okay, just give me 1 second, okay? I'm going to stop sharing and then turn off Slack, actually. Slack
Oh, is that what's happening? Yeah.
Yeah.
Yeah, that's common these days.
And the kid in the background.
Oh yeah. Well, if a 2-year-old tornado runs in here, it's part of the gig these days.
It goes with the territory.
Yeah.
Where's
Yeah,
the dog?
we're not home, but we are working. Yeah. All right.
All right. Sorry about that. Okay. So hi guys. My name is Rajesh Iyer, and over the last year and a half or so, we've embarked on this journey to build out an event-driven acquisitions platform in American Express. And I'll talk about what is acquisitions and what is the journey that we have embarked upon. And in that process, we've sort of spearheaded a lot of new technologies and a lot of new patterns. And one of them is using the CloudEvents specification, right? And then and I've built event-driven systems before in other financial institutions, and I've seen some of the issues that happen without having a common sort of envelope being there, right? And I think I'll talk about some of the issues that we've had with building event-driven systems without having a common envelope. And then we dive into cloud events, and then we'll talk about some of the benefits of having a common envelope and a common metadata structure for event-based communication across microservices. Okay, so let's dive in. So we'll talk. So I want to just take a moment to talk about what is event-driven architecture, right? Event-driven architecture at a high level refers to a system of loosely coupled microservices that exchange information between each other through consumption and production of events. Okay, so what essentially that means is that I have let's say an event bus. That event bus could be some sort of pub sub system, which is, let's say, RabbitMQ or ActiveMQ or Kafka, any of those technologies, right? Which act as my event bus. And I'm basically having a system of producers and consumers. Producers are essentially, think of them as microservices that can produce events, and then consumers are event consumers, which basically take the data out of the event bus and then do some further processing with it, right? So what are events? Events are basically, think of them as a statement of fact that something has happened, right? Let's say a customer got created, or a customer got updated, or a payment was made, right? So it is essentially a statement of fact saying that something has happened in my system, and I'm going to indicate that to the world. Okay, how do I indicate that? Through publishing that event into the bus, right? And then whoever is interested in that event. So I'm interested in, I'm an order system, for example, right? And I'm interested in all the customers that get added through the front end channels, for example, right? So I will be subscribing to the customer events, and so that I can update my local system or local system of record, right? So I'm so interested in this customer events, so I will consume that and then do that, right? Similarly, let's say somebody else is interested in order events, right? So let's say there is a fulfillment system which is interested in order events. So they're not interested in customer events, they are just interested in order events. So that is the advantage of an event-driven architecture, where you have true decoupling between producers and consumers, and you can essentially build highly scalable and distributed systems where the producing services don't know about the consuming services, the consuming services don't know about the producing services, right? And one big advantage is that I could add, let's say I want to have another system which listens to the order events. I can just plug in that service or microservice, whatever it is, to listen to that events, right? Which without disturbing my entire ecosystem. So that's a very big advantage of loosely coupled architecture, where I can plug and play and I can remove things or I can add things, and everybody's essentially listening to the bus, right? So that's the big advantage.
So the major points here that we want to focus on: you have a decoupled, properly decoupled system, and you can scale different microservices independently. You can add new microservices independently, and all you have to agree on is that contract, and that contract of sorts is the event. That's what we're talking about here.
Exactly. And then some of the benefits that I mentioned here is resiliency, right? So if one of my services in my ecosystem goes down, let's say my customer system goes down, right? It doesn't really impact my ordering system. I mean, as long as my customers are there, I could still place orders and things like that, right? So it's not like a monolith where if my entire system goes down, I'm host, right? So with microservices, I mean, this is more of a tenet of a microservice, not necessarily about event-driven architecture, but essentially, I am highly resilient because of the fact that I'm distributed, and then my blast radius is vastly minimized, because I can then control what is my blast radius if if some of my microservices go down, my entire system still stays up, or most of my entire system still stays up, right?
Failure in one domain doesn't mean a failure in another domain. Yeah,
exactly.
And actually, we didn't mention this in the intro, and that's my bad, but for those of you in the audience, we 100% want you to ask questions. There's a mechanism at the bottom of your screen that should say Q&A. If you put questions in there, Josh and I will be monitoring them, and we'll bring them up when we feel there's a nice little break. So just keep that in mind. Feel free to ask questions whenever you feel the need. So yeah, just wanted to mention that. So sorry for interrupting, Rajesh. Yeah, keep going.
No worries, Daniel. Okay, so one other big advantage of an event-driven architecture is a single source of truth, right? So when I say single source of truth, is my event bus is my single source of truth, right? So let's take Kafka, for example, right? Kafka has a lot of properties of database itself, right? Where I could basically persist events into a log-based structure, right? And I can use Kafka as a way of recording all my events in the order in which they have arrived, and I can essentially rebuild my state of my system if all of my databases go away, right? For whatever reason, right? I can rebuild my state from the events that have happened over a course of period of time, and rebuild the state of my system from that source, right? That's why event sourcing is a very powerful pattern, where you can actually take all of your event data and then rebuild the state of your aggregate or the state of your system from events, right? So I think that uh, the event-driven architecture and event sourcing essentially gives you that capability. And then, of course, you can use those events to build a stream of things, or build a stream of facts, compute some business use cases, which I will come to in the further slides, right?
Yep.
So there are a lot of other patterns and use cases that can benefit from having a single source of truth, or having a single source of events in your event bus, right?
In a way, it's really it accomplishes the same goal as a ledger, right? You get to see
Yes.
every change and every total along the way, so you could reproduce your final score, simply by rerunning the ledger or rerunning the events. That's the idea that you're describing.
Yeah.
Yeah.
Okay, so this is, I just described a spaghetti of microservices, right? I mean, organizations have hundreds of microservices nowadays, right? I mean, everybody's talking either through APIs or some sort of event-based mechanism. And these are some of the domains so this is like an online storefront example where you can see different domains. You have a marketing domain, you have an accounting domain, you have a shopping domain, you have a customer service, inventory, and all of them are large enough domains that they can have 4 or 5 services within those domains, right? So, and everybody is sort of exchanging information between each other, right? So there is no central system of record, if you will, right? So everybody has their own individual systems of record. Your security system has its own system of record. Your fulfillment system has its own record. Your accounts have their own system of record. Customers have their own system of record, and so on, right? And everybody is essentially communicating through events. So the events are basically acting as a vehicle for carrying state changes, right? So that's why there are 2 essential reasons for events. One is a notification event where I'm informing you of something. Let's say, please send an email or something like that, right? It's a notification. The other one is called a state change, where marketing says, hey, I changed a marketing campaign. Okay, here's the information about the marketing campaign in an event. Okay, somebody who's interested in that would subscribe to that, and then he would update that, whatever that business use case is, right? So similarly, I created a new customer. Hey, order system, are you interested in that? I mean, or well, I wouldn't say that, but the order system would subscribe to that customer events, or the customer updated event or the customer created event, and I would update my local order system of record, right? So that is what we are talking about in an enterprise where you have hundreds of microservices and everybody is talking through either producing events or consuming events, right?
Yeah.
So another pattern which is a derivative of this is event choreography or event collaboration, right? Event collaboration essentially means that, okay, I'm microservice A, I'm producing something, microservice B consume that and then produce something else, which microservice C consumed, right? And then microservice D also consumed that to do something else, right? So what I'm describing is a choreography of producing and consuming events that are happening between different services to accomplish a business process or a business flow, right? So there is no, so there's if you, I'm just going back to, the ESB days, right? Where we had a central ESB orchestrator or a central collaborator, which will say, okay, do this, do this, do this, do this, right? So it's like a God process where, everybody, it's controlling the entire flow, right? If that God process dies, if my ESB dies, my entire business is gone, right? It's not working, right? So with event collaboration or choreography, nobody's controlling it, right? There is no central process which is controlling that. Everybody is doing their little subset of saying, okay, I produce this, I consume this. This is my job to consume this event and produce something else. And the other guy says, oh, this is my job to consume this and then produce this, and I'm done, right? So everybody is sort of doing their bits and pieces. Nobody's controlling it at an overarching level, right? So that's another interesting pattern that comes out of this.
So we have a question coming in, and I don't think that you addressed this later in the deck, but let me know. It's about troubleshooting an event-based architecture. That's not, you don't address that today, do you?
No, I didn't address that. Yeah. Yeah.
Well, let me read the question, and if you think you can answer it in
Sure. Yeah.
like a
Absolutely.
minute, let's see what we can do.
Okay.
So it's from Sundar. He says, troubleshooting a microservice-based application is difficult. Distributed tracing with Jaeger, for example, makes troubleshooting easier. With an event-based publish subscribe architecture, how would one follow the sequence of actions for a single external API call, and how does that compare to distributed tracing? Yeah, so I think you understand the question. Yeah.
Good question. Yeah, so that's where metadata comes in. Okay, event metadata comes in, and I'll address that in some of the subsequent slides. But basically, to answer your question, uh, uh, again, it depends on the technology that you're using. Also, I mean, if you're using Kafka, you have to understand partitions and offsets and all of that, right? I mean, you have to understand that to be able to debug the problem that you have had. But outside of the technology, right, how do you correlate different events? You correlate those different events through metadata, and that metadata is essentially going to be things like uh, uh, so let me go back to the next slide. Actually, I'll come back to this, and then we'll go back there, right? So this is some of the extensions to the metadata that we've added. Okay, so you can see that there are three different types of metadata, or IDs, if you will, right? So there is an ID here, which is the second attribute here, which is the top, which basically says, okay, and I have an event. An event has a unique ID. Okay, so when I put it on the bus, I know this event has a unique ID. Okay, the second piece of information which says I have an event correlation ID. Okay, so the event correlation ID basically tells us, okay, so let's take a scenario where I publish something, and there is a consumer which consumed something. Okay, so and I want to know whether the publisher produced something and then the consumer consumed something. Okay, so using the event correlation ID, I can figure out if the event correlation ID is the same between the producer and the consumer. Okay, so there are three essential levels of that we've tried to break it down, right? So every message has a unique ID, which is the ID field that you see here, right? Sorry, the ID field that you see here, right? If you want to correlate an event or multiple events across a business process, you use something called a event correlation ID, which is essentially acting as a correlation ID, which basically says, okay, here's a producer which produced something, here's a consumer which consumed this, and it is also producing something else. And it will all use the same correlation, event correlation ID, right? So I can go to the system and I can say, okay, these are if I have to debug something, I would use that event correlation ID to measure whether I really got these things happening or not in the system, right?
That makes a lot of sense. We did that in trading software for all of the various straight through processing kinds of techniques, and otherwise there is virtually no way to tie all of these events together.
Yeah, that's right. Otherwise, there is absolutely no way to say which transaction emitted which event, right?
Yeah.
So and the third aspect of it is the application ID, right? So let's take a scenario where there is multiple events that are happening in the journey, right? Your journey is composed of multiple events, not just like a request response kind of mechanism. There is besides so let's take an example of a journey which has 5 steps in it. Okay, so that once one set of steps happens, then that results in a second set of activity that results in a third set of activity. So there's a lot of back and forth that is happening, right? Each back and forth is one transaction, okay, which I can correlate through, let's say, an event correlation ID. Okay, but how do I stitch the 5 transactions together? I stitch the 5 transactions together using the application ID, okay? Because they are all for one application, right? So that's how I am able to debug problems in an event-based systems, is through these correlation IDs or IDs, which can, so there is 3 levels essentially, right? Every single message has an ID, which is what we're talking about here. So that is one unique aspect. And then every transaction has an ID, which is the event correlation ID. And let's say the transaction of transactions, which is like, for my business process to execute, I have 5 transactions, let's say. So to correlate all of that, I have the application ID, right?
Yeah.
So again,
do
yeah.
you use any tooling on top of that? As in, I know that some of the monitoring software out there has started to do, business process monitoring. Without naming any names, there are a few out there. Have you found any solutions that really work in that way?
No, actually. So we have sort of custom software. I mean, like the Kafka Streams application that I was talking about, right? The Kafka Streams application uh, knows to match correlation IDs, for example, right? It sees the request, it sees the metadata with a particular correlation ID. It will put that in memory. Okay, I got a response with the same correlation ID. Did it match? If not, I'm going to alert, right? So it's basically custom software at that point.
Got it. Cool.
Yeah. Okay. So
Sundar, I hope that answered your question. He can't, we got to move on. So he can't answer except through chat. So,
okay. So this is a quick overview of our system, and I won't get into the details. But basically, if you look at and we are using Kafka as our backbone, so you can see there's a bunch of systems. There's a front end application here. There's a UI application which actually sends information from AmericanExpress.com, and it basically comes into something called a PSL application, which is basically a node-based application, and it then produces an event, which we called application submitted event. It goes into a topic, and then it is read by another service, which then does the downstream processing with credit and fraud and stuff like that, and then sends us a decision, right, of what has happened, right, with that application, whether that credit card application got approved or denied or pended or whatever. So we have, the other aspect of event-based programming is event naming, right? There's a good exercise called event storming, which allows you to, if you read about event storming, it basically allows you to sort of think in terms of uh, uh, aggregates. I mean, I'm going to domain-driven design, which is a little tangent, but basically, if you Google event storming, it allows you to. There's a process to actually come up with the list of events and state changes that are happening within your application, right? And that's how we have sort of come up with the list of events using that event storming exercise, right? And the one of the things that you should always strive for is to not look into the payload, right? So there's a event metadata, and then there's a payload, right? So what we're trying to do with the naming of the events is to not look at the payload, to understand what this event is, right? Because you don't want the code to always look into the payload, because obviously it requires a lot of parsing and stuff like that, right? So you look at the event name itself and you figure out, okay, the application was approved, or it was decisioned, or canceled, or pended, or whatever, right? So that's the intent of what we're trying to do. And then we have a monitoring application, which is what I was talking about earlier, which is a Kafka Streams application, which basically monitors these topics in Kafka, right? And it looks at the event stream, and it is able to determine business actions or business, it is able to execute business use cases based on the events and the metadata that is there on those events, right? For example, I'll talk about like an SLA breach use case later, right? Which basically looks at the inbound event and the outbound event coming from the other side and say, okay, did it meet the SLA? If it doesn't, it will report, a Slack alert, right? For example, right? So those are some of the advantages of real-time monitoring of the event stream, and then that results in real-time analytics, real-time alerting, real-time problem diagnosis, all of that. There's a lot of use cases that come with that, right? That can be derived patterns from there.
Yep, that makes sense. Okay, we have a couple of more questions popping in. So one of them is potentially very big or very small, depending on how you want to answer it. But Naluri has asked, how are Kafka stream services different from conventional messaging systems like JMS, WebSphere MQ, RabbitMQ, or TIBCO? And I think there's a very quick answer to that. And then I think there's an enormously long answer where we could hold our own session on just that. But
yeah,
you want to take a shot at the quick answer?
Sure. Yeah. So there's a quick answer. The quick answer is that Kafka is basically is a log, okay, is an append-only log, right? Whereas your traditional message brokers they can be publish, subscribe, or queue based, right? But the big advantage with Kafka is that from a scaling point of view, it scales horizontally very well compared to the traditional, RabbitMQ and IBM and all of the traditional brokers, right? So it has you have the concept of partitions, you have the concept of consumer groups and things like that, which allow you to massively scale compared to your traditional brokers, right? The second big advantage of Kafka is that it's a log. So it allows you to store the data for a longer period of time compared to, you can enable storage with, IBM, I think IBM and RabbitMQ and all of that also. But then I think the big advantage with Kafka is that the storage can also scale because you have, you can have multiple brokers in the cluster and each of them can have their own storage and stuff like that, right? So horizontal scaling is a huge advantage. And then the application scaling meaning you can scale your application by having multiple consumer groups, right? Consumer groups and partitions using think of partitions as lanes in your highway, right? I can basically put a message on lane 1, I can put a message on lane 2, I can put a message on lane 3, and I can basically have 3 different consumers on listening on all 3 lanes consuming messages, right? So I can achieve massive scale by that, right?
Yep. Yeah, that makes sense as the quick version. This is it's a whole topic. And yeah, I used to do the same thing with databases when I was at DataStax, which is, what are the real differences? Yeah, so we'll have to hold a whole nother session on distributed messaging and so
absolutely.
forth. But yeah. I also want to be conscious of time, so let's try to move on from there. There is a question from Bharath asking about the challenges you faced implementing these, these applications based on events. And I suspect you're going to start talking about those fairly soon as well. So maybe we just sort of move on from there. Does that make sense?
Yeah, sure. There are, again, lots of challenges with event-driven applications. I mean, I wouldn't say event-driven in general, right? I think in distributed systems, there are a lot of challenges with distributed systems, and then event-driven systems complicate that to a certain degree because of the fact that you're dealing with events, right? So I think let's focus on the need for a standardized envelope, right? So I think if you look at not doing a standard envelope, right, then you essentially, if you go back to this picture, you have lots of different services. And let's say, for example, my accounting domain services have a contract with order, okay, and they know how to talk to each other, but the rest of the ecosystem don't, right? They were built at a certain time, and it was built 2 years back, which had a different format, so on and so forth, right? So what is happening is now my let's say my order system needs data from both my accounting system and my customer system, and my customer systems messages are different, for example, right? Because they were built like 2 years back, right? So now I have to worry about understanding the customer events, and I have to worry about understanding the order events from a serialization point of view, right? So it adds up essentially, right? So I have to worry about different formats, I have to worry about different contracts, I have to worry about uh, production issues with different types of messages, serialization, deserialization issues can happen. All of that can add up in a big enterprise, right? So uh, and then again, on top of that, if I add multiple languages and multiple ecosystems, that adds up also, right? So and then metadata is again a problem. I cannot describe my metadata in a standard format. I described events. The event naming becomes a challenge because everybody's using a different attribute to describe my event name, right? So all of those challenges are there, right? uh, to get over that is where we need a standardized event envelope, right? uh, and that's where cloud events comes in. Cloud events basically enables us to describe event data in a common way, right? Basically, what that means is that you describe the metadata for the event. Things like I'll just jump into the next slide and come back to so things like your ID, your source, where this event came from, the spec version, which basically says, okay, this is the version for this event, and the type indicates my event name, right? Again, I have that one attribute which basically describes the event name in a consistent manner across the enterprise, right? Data content type, data schema is another important attribute that we use, where we can describe the schema for the payload, right? So we have implemented a schema, or we are in the works of implementing a schema registry, which basically will look at that data schema attribute and then go to the registry to validate the payload, right? The payload is basically in the data attribute, right? You see in the top, right? So I can basically use that data schema attribute to indicate, okay, this is the name of the schema for the payload. Here you go to the schema registry and validate that payload, right? Subject indicates a common subject, and then time is of course the time of the event, and then you can add extension attributes, right? Locale, line of business. I talked about application ID, event correlation ID. Product is another attribute that we are using for routing, right? So based on the product, I can have different consumers, listening for a particular product. I have, 6 pod. If you think in terms of Kubernetes, I have, let's say, 3 pods for gold product. I have 3 pods for platinum product, right? And they are just event listeners to consume, right? Consume events. So I can horizontally scale based on the product also, right? So I know that my gold product gets a lot of traffic compared to, let's say platinum. So I can add more pods. I can do things like that based on the event metadata. And that's where the event standardization of metadata becomes extremely important.
Yep. Yeah, there's another question coming in from Sridhar, and he's asking how you deal with failure, basically, as in if a particular if a particular, I don't know how to call it, from the user's perspective, if a particular action is being serviced by multiple microservices, a series of events in your parlance, and one of them fails, where does the responsibility lie to retry and reschedule and all that good stuff?
Yeah, good question. So in our case, what we're trying to do, what we're doing rather is okay, so there are two parts to that answer. Okay, so let me go back to this slide. There is the producers. So the event producers are basically responsible for retries, right? So let's say I'm talking Kafka. Okay, so Kafka has a concept of an idempotent producer where I can basically send a message to the Kafka broker. The broker acknowledges it, and I got a response back, right? So if the broker acknowledgement does not happen for whatever reason, it means that the broker is down or whatever, the producer will retry it, right? And retry that message again for a certain number of retries. And that is a configurable value that you can set up. You can say 5 retries or whatever, right? And it will basically try 5 times. And then it depends on your logic after that, right? So in our case, what we're trying to do, what we're doing is we have 2 clusters of Kafka in our data center, right? So we have a primary cluster and a secondary cluster, right? So the primary cluster has 6 brokers, and then secondary cluster has 6 brokers, right? So we try to produce to the primary does not acknowledge whatever. The second time we retry, second time it acknowledges, right? So that is one use case. Let's say the primary does not acknowledge, right, at all, right? Then we fall back to the secondary cluster, the Kafka cluster, and then we try to produce to that, right? So that is one aspect of how we implement durability in our producing of messages, right? The second aspect is around dead letter topics. You see this topic called a dead letter topic, a DLT, which we're calling it, right? It's like in your traditional messages, it's traditional message brokers. It's like a a poison queue or a failure queue, whatever they call it, right? So it essentially is something went wrong with the message itself. Let's say there is a I talked about schema validation, right? So the payload schema validation failed, right, for some attribute because of a bug in the code, right? Bug in the producer code or bug in the UI code, for example, right? So the schema validation failed. Obviously, we don't want to send it to the consumer because the consumer is going to crap out anyway. So what we do is we push that message aside to, I think of it as like a shoulder in the highway, right? I take that message and I put it in the shoulder, okay? And then we have a separate application which reads all these messages from the shoulder topic, which we call it dead letter topic, right? And it will then show that in a UI, right? So this is my application which I'm talking about. It basically consumes all these messages. You see this arrow here. It consumes the messages from my failed topic or the dead letter topic, and then it will show that in the UI. So this is the audience for this UI is basically an SRE team, right? An SRE team basically says, okay, this particular message failed for some schema validation. I could potentially in the UI fix that schema validation error, right? Something wrong with the payload. I mean, I fix that error and I resubmit that message, right? Back to the main topic. I could do that, right? So that's where the manual intervention comes in. And this is mainly for, an SRE or a production support team where they can basically look at the message, eyeball it, fix the error, and then resubmit it back.
Got it.
So that's the second level of failures that can happen with messages.
Yeah, that makes a lot of sense. It is a challenge, though. It's just another layer of complexity. that you encounter in exchange for all this.
Yeah, and that's why the
scale.
schema, the enforcement, the schema validation becomes, the contracts become very important, right? So that's why we are enforcing schema validation, where the producer of the message has a schema, and the schema is validated by the producer of the message, right, before it gets put on the bus, right? So we validate the schema from the registry here, and then we publish. Once the schema validation is successful, then we publish it to the topic, right? Otherwise, we just return it back to the client and say, okay, the message could not be published.
Yep. So again, just keeping track of time, we got probably 7 minutes left before we want to go back to Josh, and we do have a couple more questions. I think this one you could probably answer fairly quickly from Bharath. So he's wondering about latency, as in an events-based system can introduce latency. Did this affect performance at all? Is this something you encountered?
Latency in what way? I mean, well, so there is, when you say, so there is a problem of eventual consistency with event-driven systems, essentially, right? I don't know whether you want to call that latency or not, right? Eventual consistency essentially means that I publish something, it goes into the bus, it gets consumed by another service, and let's say I have an API on top of that service, which is basically getting some data, right? So that data is obviously going to be a little late because it is traveling on the bus. I mean, we're still talking about milliseconds here, right? But then typically the pattern that you employ in this case, let's take a CQRS pattern, right? I mean, so what is happening here is, let's say, we publish a message, it goes on the bus, it gets processed by the system, we get a response back, and we consume this response. So this number 7 that you see is our event consumer, which basically writes this data to a Redis database and then exposes an endpoint, which is consumed by this UI, right? So the UI basically goes and says, okay, did I get a response? Did I get a response? Did I get a response? It is basically blocked on this call, okay? So it is blocked on this call until I get a response. Okay, so that is basically, if you look at it, that's a CQRS pattern, right? So this is my command side and this is my query side here, right? So the query side is blocked until I get a response, right? So now that response could be, a second, or it could be a millisecond, depending on the delay that Kafka adds, right? And the delay that the processing system adds, right? So that's what that's the big difference between synchronous systems and asynchronous systems, right? Synchronous systems, obviously you make a request, you make an API call, you're waiting for that response in the same thread. With asynchronous systems, you're making a request and then you're getting an event back at some point, right? Now, if that event is important to you, you will have to wait for it. And that's where the blocking read pattern comes in.
Yeah, it's starting to sound a bit like the idea of a promise, really, in some of the basically. Okay, well, that actually kind of dovetails into another question Bharath had, which was about using events for synchronous workflows. But I would suggest we keep going in the interest of time. But I think we kind of touched on that well enough, at least for today. But
you could use an events for synchronous workflows through an event correlation ID. As long as you are able to correlate a request and a response, you can use it. I mean, and you'll have to basically do a blocked read, essentially, right?
Yeah.
So
it could be done. You just just have a slightly different method. Yeah. So I hate to say we got probably 3 minutes left before we want to turn over to Josh. So
okay.
So do you want to start wrapping up maybe with a few final thoughts?
Yeah. So finally, I want to just talk about event streams, right? I think event streams again is a fantastic I would say, byproduct of having real-time events, and especially with things like Kafka streams-based applications, you can do a lot of things with respect to event monitoring, uh, uh, looking for things like SLA breaches, or we look for things like applicant mismatch, where I submit a credit card application with two people on it, me and my wife, and then one of them got approved, one of them got declined. I know that, right? I mean, because I'm monitoring the event stream. It's not like I'm putting the data in a warehouse and then I get that information, let's say a day later or 2 days later. I know this immediately, right? The moment I get a decision back from the downstream systems, I know immediately that, okay, one of them got approved, one of them got rejected, right? And I can immediately send an alert to, whoever it is, uh, based on the audience, and they can take some actions, right? So I can do not just technical production monitoring, I can do business-based monitoring as well, using things like Kafka streams, right?
Yep. Okay, if we have time for one more, we have one more question in the queue, then we'll hand it over to Josh. That's all right with you, Rajesh?
Yep.
Cool. So it's a clarification from Bharath on the latency question. So he's referring to the time it takes due to publish, validation, consumption, and all the time it lost in that processing. He wanted to figure out if that has impacted you and if you've solved it in any way.
No, that has not impacted us, mainly because we are talking about a lot of processing that happens when we deal with a brand new credit card application, because there's credit checks, there's fraud checks, and so on, right? And that whole process takes 15 seconds for it to come back. So the user is basically waiting for a decision to come back for 15 seconds. So adding a couple of milliseconds with Kafka is not a problem, right? Compared to an API based request. So if you compare, if I had to do this entire thing using an API versus switching to Kafka, I would say probably I'm adding like 100 milliseconds to the whole transaction, right? And in the bigger, grander scheme of things, it's not much.
Yeah. So if it's not a high frequency trading application, it just won't matter. Yeah. All right. I think we're going to have to wrap there due to time. Josh, do you want to take us on home?
Yeah. So let me share my screen real quick. I just want to show everybody the next event real quick. Let me share. So this is our next event right here, automate microservice to API by using Kubernetes operator pattern. We got Daniel on there again, and then we have Lakmal, and who wants to pronounce that last name? I can't do it. Vasu, do you know Rajesh? So Lakmal is the Senior Director of Cloud Architecture at WSO2. Which is a cloud native, one of the large cloud native integration vendors, I think, out there. So we're excited to have him. I don't know if Lakmal's out there, but Lakmal, if you're there, hello. I think he was supposed to join us tonight. So that's going to be on March 16th. And I want to thank you, Rajesh. Thank you. I know we've been wanting to do this for a while, so really appreciate you taking the time to put this together. I know you put quite a bit of thought into it. And as always, Daniel, I want to thank you. And I want to thank you, Vasu, for sponsoring the event with Zellersoft and everybody that's participated. So, I have one request. We're looking for speakers, especially if there's any female speakers in the cloud native space. They don't have to be senior VPs or anything like that. It could just be any engineer that's doing some really interesting things and the cloud native, working on some cloud native projects. So please let us know, or if you want to speak, just reach out to me directly and we can have a conversation on that. I think that's it, guys. So what time is it? Did we finish right on time?
We're on time.
Right on time. Awesome. Yeah. Okay, great. I think that's it. We'll have this recording out soon. And thanks, everybody. Thank you, Rajesh. Take care now.
Thank you,
See
everyone.
everybody.
Be well.
All right now. Bye.
Thank you, guys.
Thanks, Vasu.